Hello, welcome to these notes, the first section in Chapter 10, Introductions to Conics, Parabolas. So the objective of this section is to find the equation, focus, and directrix of a parabola. We're going to see parabolas in a way that is really different from what we've seen in Algebra 2, for example, or in pre-calculus at the beginning of the year. We're going to see parabolas with a geometric definition. So the term conics comes from this here. This is a cone in blue, and as you intersect this cone with a plane, the cut through the cone has different shapes. If you cut the cone horizontally like that, the shape is a circle. If you cut it with a slight slope, then the intersection is going to look like an ellipse. And if you intersect the plane with a plane that is exactly parallel to this line here, exactly parallel, then you'll have a parabola. If you tilt the plane further, it doesn't need to be vertical, but here it's vertical, then you get a hyperbola. So it's completely different from what we're used to see when we talk about circles, parabolas, hyperbolas in Algebra 2 or pre-calculus until now. The general equation of conics is like this, and in our case this year we will always have b equals 0. So everything we're going to study in these sections will have no term in xy. It's going to be ax squared plus cy squared plus dx plus ey plus f equals 0. And a, c, d, e, f are constants. So, geometric definition of a parabola. Here is how we can draw a parabola simply with geometric concepts. A parabola is the set of all points that are equidistant from a fixed line and a fixed point not on the line. The fixed line is called a directrix, and the fixed point is the focus. So imagine this figure here with only the line and the focus, and the parabola is not here. How could we find where it is? Well, it's made up of all the points that are at the same distance from the focus and the line. So the easiest point to find is the vertex. It's right in between the focus and the line. But the fact is that every point here on this parabola has the same property. For example, this point here is at a certain distance from the focus. It's at the same distance from the line. True for this point too, true for every point. And if we just follow this definition, we get a parabola that has exactly the same shape as a parabola you would define by y equals ax squared plus bx plus c. The standard equation of a parabola is given here. There are actually two types of equations we're going to see, because now we're also going to talk about parabolas that open left or right. So firstly, if the axis is vertical, that's what we're used to have in pre-calc and algebra 2, the general form of the equation is x minus h squared equals 4p y minus k. We will see in more detail what h, p, and k can be used for, but h and k is the vertex. Now, if a parabola is horizontal, it opens left, it opens right, then the standard form of the equation is y minus k squared equals 4px minus h. So here we have 4 figures of all situations that can occur. The parabola opens up, opens down, opens right, opens left. This p that we saw earlier in the equations is actually the distance between the focus and the vertex. Now, it's not just a distance, it's a directed distance. What does it mean? It means that p can be negative. If the parabola opens up, then p is going to be a positive number. So let's say there's a distance of 2 between these 2 points, then p equals 2. On the other hand, if this distance here is 1, then actually p is going to be negative 1. So when the parabola opens down, p is negative. Same here, when the distance between the vertex and the focus is 1, let's say, then here p equals 1 because the parabola opens right. And finally, if the parabola opens left, p equals a negative number, which is the distance between the 2 points. When we solve exercises like we're going to do now, it's really useful to realize that we're always solving only 2 kinds of exercises. So either you are given an equation and then you need to find p, h, and k, and with that you're going to find information about the parabola. So let's say you are given a certain equation and the question is, what is the position of the vertex? You will go from the equation, find p, h, and k, and with p, h, and k you will find the position of the vertex. The other kind of exercise is just backwards. You are told that a given parabola has, let's say, a focus at the point 1, 3. You are told that it opens left, etc. From these information, you can find p and h and k, and from there, you can write the equation. So there's really only 2 kinds of exercises. One is going from the equation to informations, one is going from informations to the equation, and it always goes through figuring out these values. To figure out all of that, we're going to use a table that is given at the end of your note. I'll show it to you here. You have 2 columns. If the parabola opens up or down, then you need to rely on all the information in this column, the first column. If the parabola opens left or right, then you have to rely on the information in that column. And you will be given this table in any quiz or test with just 1 or 2 things missing that you'll need to learn, but most of it will be given. For example, the focus, if a parabola opens right, will be h plus p, k. You don't need to know that by heart, it'll be given to you. So let's see the first example, and I'll try to keep this here on the screen. Find the standard form of the equation of the parabola with vertex 4, negative 2, and focus 1, negative 2. So it's pretty clear here we have 2 informations about the parabola, and we're looking for the equation. It's great to do a little sketch for the situation. It helps. We know if we see that the vertex is here and the focus is there, given the information, it's clear that the parabola is opened to the left. So this tells us we have to follow information in this column. And our solution, because we're looking for the equation, is going to be something like that. Y minus k squared equals 4p x minus h. Now if you look here, we know that the vertex is hk. So given that the vertex is 4, negative 2, it's very easy to figure out h equals 4, k equals negative 2. And finally, to find p is the distance between the focus and the vertex, and you can use this formula, h plus p has to be equal to 1 and k equals negative 2. You can find that p equals negative 3. Now we have h, k, and p. You can just plug in all these numbers and you get y plus 2 squared equals 4 times negative 3 times x minus 4. And if I just multiply 4 and negative 3, I get the standard equation. The next exercise is the other way around. We are given an equation and we have to find where the focus is. So firstly, we need to rewrite the equation we are given in standard form. We don't know yet where we are, although we could guess, because we know this parabola opens down because a equals negative 1/2. But putting this equation in standard form, we move the y, we multiply by negative 2, and then from here to this line, we have to complete the square. Negative 2y equals x squared plus 2x plus 1 minus 1 minus 1. I don't know exactly how you learned how to complete the square, but basically you have to add 1 and subtract 1 in order to have a square here. X squared plus 2x plus 1, and then negative 2. So x squared plus 2x plus 1 is equal to x plus 1 squared. And right now, if we haven't noticed it earlier, it's quite clear we are working with the first column because we have a x plus 1 squared. If we continue to simplify and to bring this equation to look like the standard form, we add 2, we factorize, and eventually we compare this negative 2 times y minus 1 equals x plus 1 squared to the standard equation 4p y minus k equals x minus h squared. So we can very easily find now that p equals negative 1/2, k equals 1, and h equals negative 1. So we are in the first column. The question was about the focus. Where is the focus? The focus is h, k plus p, therefore the focus is negative 1, 1/2. Parabolas have a very valuable property, which is shown here. If rays that are parallel to the axis hit the parabola, if you imagine it was like balls bouncing on a wall, all the balls would bounce on the wall and find themselves going through the focus. Same thing the other way around. If any ray leaves the focus in any direction, for example like this, it'll bounce on the parabola and then be parallel to the axis. So this property is really very useful. It's used in many ways in real life. One of them is shown here. I have a picture. So here's a microphone with a parabolic mirror like that, and when you use that, all the sound waves that hit the parabolic surface will focus in the middle where the microphone is. So that's how, when you see sports on TV, you can hear people talk, you can hear the players, what they say, even though it seems like nobody's around with a microphone. These allow you to hear very clearly what is said very far away. So on the sidelines of each of its televised football games, the FBTV network uses a parabolic reflector with a microphone at the reflector's focus to capture the conversations among players on the field. If the parabolic reflector is 3 feet across and 1 foot deep, where should the microphone be placed? So the microphone needs to be at the focus. That's where all the rays that are parallel to the axis will bounce and congregate. So to simplify this exercise, we can decide to place the origin at the vertex. So we choose that the vertex is at 0, 0, and now given that the parabolic reflector is 3 feet across and 1 foot deep, this is 1 foot deep and it's 3 feet across. So this point up here is at coordinates 1, 1.5. The question is, where is the focus? Y minus k squared equals 4px minus h. I found this because it opens right. That's the way I drew my little figure. So I know the equation looks like that. The vertex is at 0, 0, which means h equals 0, k equals 0. The equation becomes y squared equals 4px. Now, given that there is a point on this parabola that I know, the point 1, 1.5, I can plug the point in and see what I get for p. So if x equals 1, y equals 1.5, I get this equation, p equals 0.5625. Given that 0.5625 is p, it means it's the distance between the vertex and the focus. Therefore, I know that the microphone, or the focus, has to be 0.56 feet from the vertex. That's all. So just at the bottom here you have the summary. I hope this helped you.